Hi, my name is Mark O'Neill. In this video, we're going to be talking about the physics of sound and the physics of music. The first thing to know about sound is that it's just changes of pressure in the air. If this air pressure pattern is repeating, then we get waves. These waves can be fast or slow, and this can make them sound higher pitched or lower pitched. We can define a new term to help us think about this: frequency. Frequency is how many times this pattern repeats every second. So, a high-pitched sound will have a higher frequency, and a low-pitched sound will have a lower frequency. We can also think about the amplitude of the sinusoid, or how big it is from top to bottom. We can increase this to make louder sounds, or decrease it to make quieter sounds. We can now understand how a guitar makes sound. When I pluck a string, the string vibrates at a frequency, and pushes the air around it by the same frequency. Different frequencies make different notes, and we can stack these frequencies in special ratios to make chords. But this sinusoid doesn't sound the same as this. Music would be quite boring if everything sounded like this. So what makes a guitar sound different from a piano? Well, this is known as timbre, or what makes things sound unique, even if they're at the same pitch. See, in every note, there's a fundamental frequency, and then many more frequencies stacked on top of it. These are called harmonics, and they're similar to the way that we made chords, except now there's a lot more of them, and they're not always in the special ratios like we had before. When you combine all these frequencies together, you get the actual sound wave from a guitar. How are we able to tell that this is the sound of a piano, and this is the sound of a guitar? Well, your brain probably does something like a Fourier transform, which is described by these scary looking equations. These equations can turn a signal like this into this. This is a frequency spectrum of sound. Here we can pick out specific frequencies of sound and see how loud they are. Notice how the fundamental frequency, the main note, is the same for both, but the harmonics are different and give each instrument their own unique sound. I hope you learned a little more about the physics of music. Thanks for tuning in.